Now I would like to introduce our third presenter for this in the flow of the event, Mr. Sumit Sethi. He is presently working as technical architect. He is a technology enthusiast and thought leader with vast experience on data and cloud engineering. His key focus is on building cloud data warehouses, building enterprise data models, data architecting, designing, and architecting big data solutions. So Sumit would take up the latest trends and technology section. Over to you, Sumit.
Thanks, Ruby. Uh, Hello, everyone. So for next 20 to 25 minutes, we'll be focused on how technologies have evolved, what are trending technologies right now, and which one are the established one in the industry. And of course, you guys are free to choose any technology for implementing the ideas and innovation that you guys must be thinking about Ideathon. And this session will give you a fair idea what technologies can be used for what kind of use case, so that you'll have an idea about it. So the agenda would be like this. We'll be talking about the current state of IT industry, what we are thinking the future to be, and how technologies are empowering the world right now, how data and cloud are important right now in the IT industry, how they're reshaping it, and the list of trending technologies which definitely that you can look forward to use in your implementations. So state of IT industry. I think the first computer was invented somewhere in mid of 20th century, and then came in the big mainframe systems, and then the personal computers were introduced, and then in 1980s Windows operating systems was introduced. But what I think what evolved and what brought the revolution was the internet, and since then there is no stopping at all. In 1998, we had Google. In 2001, we have Apple iPod. 2004, we have Facebook. 2007, iPhone has been introduced. Touch phone market has totally been changed due to that. 2008, Android operating system have been introduced. 2006 was the first year where the first cloud service was introduced. That was from AWS. And now situation is even robots are becoming citizens. So amazing, right? First humanoid robot called it Sophia got citizen of Saudi Arabia in 2017. So it's evolving crazily, and there is no stopping at all for this. And while all of this was happening, I think nobody would have thought that developing nation like India will build such a massive industry around it. But definitely, thanks to engineers like you and firms like Impetus, which took the IT industry to such high. And a lot of you must be wondering, like with current pandemic situation, what gonna be the impact on IT industry? But for you all, the good news is IT industry is showing really good positive signs right now, and it's growing even better than previous years. And in fact, with the emergence of path-breaking technologies, I think Chetan also iterated the list of technologies like artificial intelligence or IoTs, blockchains, machine learning, cloud computing, RPA. In fact, robotic process automation, which is also getting introduced into the systems right now. I think with all the list of this technology, the IT industry future is looking really bright. With the data engineering and cloud technologies definitely being a key to the future. And according to Gartner, I think most of us are already known to Gartner, which is world's leading research and advisory company. It is estimating the growth of IT industry to be $200 billion in 2021. And further, it will rise to $220 billion in 2022, which is definitely a massive amount. So in a nutshell, IT industry is going nowhere. It's still standing strong, and it will go really strong in future. So how technologies are empowering the world right now? We talked about how they are evolved. Now, what is the impact of technologies on overall world behavior, or I should say, how the world is behaving on top of technology? So a lot of things have been introduced. TV, we'll start with TV, and then mobiles, and then social media, and then wearable devices, and connected cars and whatnot. But in fact, before talking about technologies, let's talk about data. Uh, as Chetan also said, we are talking about data right now. Most of the countries are talking, companies are talking about data, which is really making high impact on IT industry. It's key to every business nowadays, be it structured data, semi-structured, or even unstructured data. And this data can range from terabytes to petabytes or even exabytes. Our developers, Impetus developers, are working on petabytes and exabytes of data on maybe daily basis. And enterprises are using this data, especially to answer their business questions. They are generating insights out of it. So this slides particularly gives you a brief example how the data is growing up. Say for example, Facebook, it's like generating 350 million photos per day, which is massive. Google is now processing around 3.5 billion searches, or maybe around 24 petabytes of data per day. Twitter, 500 million tweets per day. WhatsApp, another app which is generating data in counts of billions. This data is growing rapidly and there's no stopping to it. And we have characterized this data into four big V's. Uh, One of this is volume. We are referring to volume as the size of the data that needs to be analyzed and processed. A big example, a normal example of data size would be a number of credit card transactions which are getting generated in a country in a day. That's a huge amount of data. Second, we talks about velocity, which refers to the speed with which this data is getting generated. For example, Twitter messages or Facebook posts, maybe. Third, we are talking about is the variety of data. I mean, we know that data is coming from a great variety of sources, and this will bring variety of data as well. So it could be text files, images, videos, audio files, presentation, and whatnot. I mean, there is no limit to data. There is no limit to the variety of the sources that we can get from various sources of data. Fourth V is a really important one. We call it as a veracity of data. So we talked about data is getting generated, but important is what is the important part of data that can be used, and what is the quality of that data that can be used to analyze and bring out some insights out of it. So a high veracity data example could be it could be like generating of medical experiments or trials, which say we are generating medical trials, right? And all of data is responsible for generating any insight of it or out of it. But I think not the amount of data which is important. What matters most is what organization going to do with that data. And the data can be analyzed for insights and better business decision, as I said. It can be analyzed to way to optimize the cost involved in a product development or time reductions or new product development, in fact, and smart decision making as well. Many use case can also be implemented on top of data, like fraud detection, price optimization, product recommendation that you usually see in Amazon or Myntra. Healthcare use cases like treatment recommendations, calculation of risk portfolios, all of these kind of use cases can be implemented on top of it. And this is just a small list. Innovators are thinking way more than this, and they'll definitely come up with something really good in future. Okay, this slides give you a real picture how the data is growing right now. This says that the sum of world's data is expected to swell to more than 5 times of its current size by 2025. This will more than hundreds of zettabytes. You can't even count the zeros in it. I mean, this is really massive. Okay, so we talked about data. We talked about growth of the data, which is not in control right now, and it's good that it's not in control so that we can have more data to get more insights. But the question is just the data enough? How about storing this large amount of data? How about the computing power which is required to analyze this data? These are the basic problem statement which most of the organizations have right now. As we know, there is no limit to growing data, including real-time data or maybe streaming data. And this data are coming from multiple sources. But the problem is there is a limit to on-premise infrastructure which can hold this data, which can compute this data. And this is where the cloud computing came into picture. And as Chetan also reiterated, we are looking onto data and cloud. Now Impetus is called as data and cloud company. And now, since most of the businesses are also turning to cloud providers like AWS, GCP, Azure, to store, manage, and compute their data. There are more key players are also getting introduced as part of cloud providers like IBM, and many more such providers are available in the market. But these are the three key cloud providers that we usually works with. And theoretically, cloud provides unlimited storage and compute, and it is elastic as well. And you can access data globally all over the internet. So it will not be an exaggeration saying that data and cloud definitely go hand in hand, and it definitely gives a chance to innovators like you who has great idea but have limited resources. So any idea that you are thinking about that cannot be implemented on on-premise servers, you can definitely think about the cloud, and it'll be with a minimum price that you can implement, and you can use the services from cloud. So best of luck to all of you using cloud as your one of the solution. The next slide talks about how this cloud services is jumping up right now. So it was $242 billion in 2019. And we are expecting it to be around close to $700 billion in 2025. This is a massive industry, and there is great scope in cloud and data. Okay, so we have talked about how IT evolved, how data is growing, how cloud is important. Now we are talking about data engineering. Now, this is another really interesting aspect, which is getting a lot of traction recently in the market. It's basically building pipelines to transform and transport the data into highly usable state, where the data scientist and end user can use it to generate the business insights, definitely. Now, the reason data engineering is really getting a lot of traction is we have multiple sources, we have multiple storages available in organization. But when a data scientist or an end user try to query that data, they have to think about where to go and query the data, how to query that data, because there are a lot of technologies involved. Let us consider an example of a customer's data. One of the system might contain information about billing and shopping. Another system might contain information about order history. One more system is introduced, which is having information about the customer support and their behavioral information. All of these data combining actually can provide a 360-degree view of a customer. But the problem is they are all independent to each other, and it becomes really difficult for anybody to query the data from different sources and then generate some insights out of it. And data engineering is making this task really easy, combining this data together. There are multiple ETL technologies that are getting introduced. There are open source technologies as well, like Apache NiFi, Airflow, AppFlow, Talent, Open Studio. These all can be used to create pipelines to transform the data. And since, as I said, like a lot of customers are using databases like Oracle, SQL Server. In fact, NoSQLs are also now part of the applications like MongoDB or Cassandra. But the problem is there is no common source. And this is what the organization are targeting, to move it to single source of truth, to cloud warehouses like Snowflake, AWS Redshift, Google BigQuery. And these are providing a real platform to data analysts and data science to generate insight on top of that. Again, data engineering, as I said, becoming an integral part of projects where the data needs to be curated or transformed or remodeled to make sure that the end users are convenient to fetch the data and generate insight on top of that. There are definitely multiple use cases that can be implemented on top of multiple data sets or the data sets that we have brought into a single source of truth, like change data capture. This is where we are bringing the real-time change data from source to the target. Like this will make sure that if there are any banking transactions which needs reported to be generated within hours, that can this kind of use case can be really helpful. enterprise level common data model. As I already talked about it, a lot of organization not thinking about just having a single source of truth. So if they are going for a single source of truth, they definitely have to have a common data model. And this data engineering and the ETL tools are really helping for that purpose. Recently, as we all know, a lot of mergers and acquisitions are going on. Uh, it's really difficult to combine the data models of multiple organizations once they are acquired or once they are merged. Data vault is another use case which can be implemented, and like satellites, links. These are just the terminology for data vault. This all can be used to combine the data model of multiple organizations seamlessly. Key technologies for data engineering would be, like as I already said, Snowflake, AWS Redshift, Google BigQuery. Open source technologies are like MongoDB and Cassandra. ETLs are like Apache NiFi, AWS Glue, and a lot of cloud providers are also providing the ETL options which can be used. AWS Glue is one of that. And talking about Impetus, so Impetus has high degree of specialization and highly skilled trained engineers and architects both on data and cloud. And I think Chetan has already informed about multiple products on data and cloud, which talks about workload transformations, data streaming, analytics, and many more. So now talking about the trending technologies right now. Um, we have talked about cloud computing, right? But none of the technology is 100% complete. And cloud also has some challenges related to it. Say, for example, you have a low bandwidth issue at your end. It will be really difficult to transfer the data from your end to cloud or getting the response back from the cloud. Low latency. Data security is another issue with the cloud where you are moving your data to third party. If you're not connected to internet, how would you access the data from the cloud? So these are some key issues which are still available or which is still existing with cloud technology. And this is where the edge computing uh, comes into picture. Next slide, please. Okay, so to define edge computing, how it actually works is data is processed at just the periphery of the network rather than at the cloud end, which is the periphery which is close to the originating source of the data. It can be the device itself from where the data is getting generated or any of the local server. Again, this is not cloud. This data will definitely be transferred to cloud once all this processing has been done either at the device level or the local server. So the advantage of this edge computing is any kind of critical data which is on the edge can be provided right at the time when it's needed, rather than waiting or getting the delays for the cloud. The best example for edge computing could be an autonomous vehicle. Now consider an example where a passenger is crossing in front of an autonomous vehicle. Uh, the vehicle should stop immediately. It should not rely on the cloud to send the request and then wait for the response. By the time, there will definitely be an accident. Now, where this computation or where this calculation has to be done, it has to be done either at the car itself or maybe somewhere close to the network where you can get the instant response. So this is where the edge computing comes into the picture, where we need the response right at the moment when it's needed. Another example can be in-hospital patient monitoring. So hospital definitely is matter of life and death. And again, any delay can be fatal here. And it is important to provide the right time notification to the doctors about patient conditions. Same condition, I mean, same use case, we cannot rely on cloud for the request and responses. We cannot afford any delay. And in case of emergency, it should provide the right time notification to the doctors. So this is where the edge computing again become a very important technology in nowadays. Security solutions, again, we need real-time data for any of the potential threats that is getting generated, and need to alert the user at the same moment. Again, no delay can be avoided. We cannot wait for request and response, and thus edge computing is making really an edge in the rest of the technologies. Predictive maintenance for manufacturing unit is another use case. Key technologies are All of the cloud service providers are providing edge computing services. So you can pick any of AWS, GCP, or Azure services for that purpose. Okay, so next is artificial intelligence and machine learning. They are another hot topic in this industry, and I think most of us are already aware. At least terminologies are aware to us. Uh, let's talk about AI first. It basically enables a machine to simulate the human behavior. An example for this could be smart assistants or self-driving cars, basically. Machine learning, it is a subset of AI which allows a machine to automatically learn from the past data without even programming explicitly. So these are two important aspects where we are bringing more automation. We want devices to learn, or we have that algorithms which make things to learn from the past use cases. See, many of the use cases can be implemented using machine learning. For example, credit card fraud detection, face detection and recognition, robotic surgeries are another important use cases. I think most of us have already heard about, like, robots are doing the surgeries. So they have to learn from their past use cases and past experiences. Based on that, they can go ahead and do the surgeries. Financial trading, recommendations that you see on maybe Amazon or Google ads. These are all use cases of AI and ML. Key technologies that can be used for AI and ML will be deep learning, natural language processing, speech recognition. Key programming languages are R, Python, and Java for this. So next is virtual reality and augmented reality. I think most of us have played Pokemon Go, right? And could be the best example for AR or a VR. Uh, the definition of VR can simply be like it's a computer generated simulation in which a person can interact within an artificial 3D environment using some electronical device like Oculus Quest or Sony PlayStation VR. And while AR adds a digital element to a live view by using the cameras of a smartphone, like holographics displays, smart glasses, uh, and there are multiple devices available right now for AR as well. Excuse me. And what kind of use cases that can be implemented using AR or VR maybe? Travel industry is definitely getting benefited using VR technology. They are providing virtual tours to hotels and hotel rooms. They are allowing customers to experience what hotels looks like before they even arrive to the hotel. So this give a real life picture to the consumers, and based on that they can decide whether they have to go for this particular hotel room or not. So this is really bringing the revolution in the travel industry. Real-time product demos. This is another use case for AR. Uh, Earlier, what used to happen is usually the vendors used to take or transport the products to the client to showcase them, or use technical drawings or photographs to showcase the products. But now clients can use AR to see the product instantly. I mean, they need not to travel. There is no logistics involved. They simply can use the technology and can have a look at the product. Healthcare, again, this is getting tremendously benefited with virtual reality and augmented reality. Treatment to phobias and anxiety are recommended based on analyzing how patient reacts to any kind of virtual scenarios, which can be generated using the AR or the VR devices. Education and training is another industry where I think Byju's is the great example of it, where they are using simulation to explain the scenarios for science and mathematics. Key technologies that which is getting used for VR and AR are they're mostly the software development kits available in the market, like Vuforia, AR Kit, AR Core. If you don't want to use the software development kits, you can always go for the programming languages like C Sharp, C, C++, Java, and Python. Okay, So another hot technology, I think blockchain, and I think everybody is aware of Bitcoin, right? Blockchain is the technology behind Bitcoin, and blockchain is, if we want to define blockchain, it's a growing list of records which are called as blocks basically, and which are linked together using cryptography. Uh, so each block actually contains a cryptography hash and a transaction data. What transaction data is getting generated between the two transaction or multiple transaction systems, and thus they form a chain and then called a blockchain. And to define it further, there are like these are like digital ledgers of transaction duplicated and distributed across the entire network of computer systems. Uh,
I think there is a network glitch at Sumit's end. Um, okay, so until he joins back, I would like to, because there are certain questions, if Raghavendra, Chetan, if you would like to take up and answer those questions, we can utilize the time that ways. So it's on the
Sure, sure.
similar lines, right? So in the similar lines, what Sumit was addressing about the technologies. So there is a question on the board which says, what are different cloud services available for AI and ML?
Sure, I can take that up. Is Sumit back?
Not
Uh,
yet, I think.
all right. So every cloud is offering. Um, so look at it from a perspective that these services are again classified at the different levels, right? So as basic service, basic infrastructure services to platform, and then well curated domain specific services. So every cloud provider right now is offering services around, like take an example of AWS, whether you have the whole SageMaker infrastructure available for doing complete end-to-end AI and ML implementations. But that's not the thing, right? Where you can just come and deploy your own, develop and deploy your own ML models. What each of the cloud providers is also offering now is specialized services around, say, vision, speech, sentiment analysis, uh, you know, or real-time anomaly detection and whatnot. So these are like one level of services which are available, the kind of services which are, I would call it as a high-level services. And then nowadays, what's also happening is because lots of people are also contributing from outside from a marketplace standpoint. So not only cloud provider, but also there are lots of third-party services which are also available on cloud, which people can simply use. And these are specific to certain domains. For example, there could be services around, say, textile and garments. There could be services around healthcare. There could be services. There are services around, financial analytics and so forth. So all the different types of services are available. What it is making happen is making the life easy because now people can focus on specific problems that they have to deal with instead of trying to create solution and solving each and every problem themselves.
Right, Chetan. Okay. So, yep. So I've also got received the message from Sumit that he's joining in and back in a minute. I guess there is some power glitch. So should I take one more question on the board? It's again related to cloud computing.
Sure.
Okay. So the next question says, what are the prerequisites of learning cloud computing? If one knows core Java, is it suitable to deal with cloud computing or any other language that they need to learn?
Sure. I think a good question, and I'm sure that people who are just starting on cloud, it is coming from them, and it's very valuable question from that perspective. Again, there is no restriction in terms of who can work on the cloud and who can learn the cloud. As a prerequisite, people should have understanding of distributed computing to kind of get an idea of how cloud works, right? Because ultimately it is. Am I audible?
Yeah, Chetan, you are.
Uh, Okay, yeah. So because it's ultimately it is a distributed computing model. So people should know the distributed computing and the concepts around that. And the next thing is obviously as part of engineering we learn operating systems and database management systems, right? So most of the things that we do on cloud, if people have understanding around memory management, CPUs, processors, right? So I think that is a good baseline for learning the cloud. In terms of technology and language, I think the next part of question was about Java. Is it the right next step to get to learn cloud if someone knows Java? So again,
Yes.
cloud is the de facto for future, right? Anything and everything will touch a cloud. Either it will be fully hosted on cloud, or it will be partially hosted but integrated with some on-prem services. So cloud is going to be the de facto. So that's where if you currently know Java or Python or anything else, right? Or even if you don't know the programming as well, there are always services on cloud which you can simply learn and expand your technology knowledge. So it's just the de facto, and that's where you should just move on to learning cloud.
Sure. Thanks, Chetan, for addressing these questions. I can see Sumit. Sumit, can you hear us?
Yes, Survi, I'm so sorry. The power went off.
No issues, no issues. So there were certain questions which Chetan addressed. There are a couple of more which we can quickly take up post you are done with your presentation.
Sure. So let me continue with blockchain then. I was talking about what the blockchain is. So again, from definition perspective, it's more of a digital ledger of transactions, which is duplicated across the network of computer systems. And it records information in such a way that it cannot be changed or hacked. And this is the biggest advantage of blockchain. Since this cannot be changed, the key benefits that we have is the trust and the security. So any application which needs high level of security, like banking, is one of that case. It in fact also allows the cost savings, as no third party is getting involved in data transaction, and we can track the data which is shared across a business network. So these are basically use cases that can be implemented on Bitcoin, like secure sharing of the medical data, smart contracts. All of these use cases are basically focused on, since data can never be changed, it's immutable, and that's the reason these kind of use cases can be implemented, like logistics, money transfer, cryptocurrency, etc. And there are key frameworks are also available in the market for Bitcoin, which are Stellar, Ripple, Ethereum, and Quorum. I think if anybody has idea about cryptocurrency, these are the key frameworks which are getting used to implement the cryptocurrency as well. Yeah. So next is Internet of Things. As we know, like we are wearing smart watches, fitness trackers, right? And there are billions of physical devices now around the world which are connected to internet. All of this data is getting collected, and then this data is either shared with after some analysis or some business insights, or in fact the reporting as well. So to define Internet of Things, it'll be like things which are embedded with sensors, so which actually generates the data and provide it to either cloud or any kind of server. And there are softwares as well which connect to these devices and exchange the data over the systems over the internet. So these are the devices which you generate the data and then can be further analyzed. The use cases that can be implemented using IoT is autonomous and connected vehicles, and more commonly these are like called as connected cars. This could be a great example which I can provide the detail on it. Any vehicle which is connected to internet can be called as connected vehicle or connected cars. They share the data to external devices or services. And this, if you have ever heard about, starting or stopping the car remotely, or opening the sunroof remotely, checking the climate control, adjusting the car's climate control automatically. This is all based on the information that it receives or it sends to the servers. Another interesting feature of a connected car is like geofencing, which actually can alert the user if the vehicle is beyond any, the set of boundary that has been that has been tracked by the user. Uh, in case of accident, the cars can generate the emergency SOS signals. So these are all the features that an IoT device can have. As I said, there are smart watches, fitness trackers, wearables, smart security for business and homes, which are also getting involved as part of IoT technologies. Key frameworks that you guys can use to implement as a KA IoT device, Hive IoT, and Z IoT. Okay, so next is intelligent process automation. I think most of us are already aware about RPA, which is robotic process automation. It is a process in which we can use some softwares which can process high volume of tasks which are repetitive or time consuming. For example, tasks like data entry jobs or chatbots where the customer sends the request and somebody has to respond on top of it. These are all time consuming and require human to be behind it. But with the introduction of RPA, this is all got automated. But when we add artificial intelligence to RPA, it becomes intelligence process automation. And there are multiple use cases that can be implemented using IPA. Say, for example, churn prediction. IPA can actually provide an alert of the churn risk of a customer. It can identify a customer if the customer is planning to get out of their product or to cancel their services. So it can this IPA can in advance alert the customer, the executives about the customers, and then they can make sure that they retain the customer based on those alerts. Other use cases which can be implemented are insurance from the insurance domain, like claim processing. From a telecommunication domain, it's more of a automated customer request that can be managed. From financial services, it's more of a mortgaging of the cross selling of the mortgages. So these are the key use cases that can be implemented. The tools that can be used are UiPath and Automation Anywhere. These are like paid tools. There are no open source tool I am aware of right now, but IP can be implemented using any of the tools. And programming languages that can be used are C# and Java. So yeah, what we have talked so far is a list of technologies, data engineering, cloud, but I'm assuring you what we have talked so far is just not even the tip of iceberg. There is many more things to talk about, and the journey of technology is never ending. And with this, I'll take a stop. Please let us know if you have any questions related to Impetus, Ideathon, or technology.
So Sumit, there were a couple of questions on the board, as I said, which has been addressed by Chetan when you were not there. There are a couple of more. I'll pick two of them. Okay. So first says, like, are cloud or big data technologies like Hadoop or NoSQL not the trending technologies?
Okay, so I have not included that in the list. It does not mean that these technologies are not getting used, but for cloud, it's definitely not trending anymore because it's a norm. Every organization is using it. Every organization is moving to cloud now, and uh, since we know that, right, it's becoming really very difficult to store and compute large set of data on premise, and all these big data technologies are also getting moved to cloud. For example, you can use EMR, which is like Hadoop on AWS. NoSQL like MongoDB and Cassandra are also available as software as a service in the cloud. So these technologies are not going anywhere. These technologies are here to stand, but now the norm, not the trend.
Sure, Sumit. So since we are not left with much of the time because we have overshot the time, in fact, I'll just pick one last question, which says, are there any open source tool available for data modernization?
Yes, there are actually. There are ETL tools available in the market, open source. Apache NiFi is one of that I already called out. Another is Talent Open Studio. Clover DX is another one. Havodata is another one. There are multiple tools available in the market which are open source right now, and all are having features sufficient enough to implement key data modernization requirements. So yes, there are.
Sure. Thanks. With this, I would like to end the event for the day. There are certain more questions which we can like address one-on-one through our Pathmaker site. Okay, the mail areas that we use. So we'll be addressing it through them. However, I would like to once again thank all the presenters for sharing such useful information and addressing the queries of the participants. And I would also like to make special thanks to all the folks and the participants for registering and showing interest in Ideathon. If in case you have any further questions, feel free to reach out to us at pathmakers@impetus.com, and wishing each one of you all the best once again. Thank you.
Thank you, everyone.